Welcome students. Today we'll look into a problem from JEE Advanced 2014. Why I'm taking this problem? To not show you how we solve the problem with the vector and all those things. Okay, those are technical things. Let's leave it aside. The main purpose of showing this problem to you, that what goes wrong if you leave out physics and only think of solving a problem using mathematics. So this problem that I've shown is available on internet. There are two solutions to it. One is completely wrong. Even AI suggests you the wrong solution. And there is one correct solution as well. But why do we actually get to the wrong solution first? Let's look into it and where we ignored physics in there. Okay, great. So it's given that a rocket is moving with an acceleration 2 meter per second in a gravity free space. That means there is nothing related to gravity here. It's only one acceleration in particular direction, x axis. And there is a chamber inside it which is of length 4 meter. Two balls, A and B, are actually launched towards each other from two ends of the chamber at 0.3 meter per second towards x-axis, and B is launched at 0.2 meter per second towards minus x-axis. So because this is a non-inertial frame, what we need to do is we need to get inside this chamber and then try to solve the problem. Whenever we get inside the chamber, let's say I'm sitting at this position with my y and x axis, acceleration on these two bodies A and B, okay, there is a pseudo force applied and the acceleration is exactly the opposite. So for this particle B, the acceleration is in this direction of, sorry, acceleration in this direction of 2 meter per second square, and for this also the acceleration is in this direction of 2 meter per second square. Okay, now let's actually put everything in vector form so that we do not make any mistakes. Okay, so let's take the velocity VA is equal to 0.3 I. I'm not putting in the units. So because it's going towards positive x-axis, then that means it's I. What about B? B is minus 0.2 I because it's going towards negative x-axis. What about the acceleration of A? Both of them are actually going in this negative x-axis, so it will be minus 2I, and so will be for B particle, which is minus 2I. Okay. Now to solve these kind of problems, what we'll do is we have the relative distance between them. That means the displacement it needs to cover. So I can say SAB vector from A to B is going as positive 4I if I go from this to this direction. So if I go from A to B, then the relative velocities that we'll calculate, which is VREL, needs to be from A to B. So it will be VA minus VB. And that will be equal to what? This is minus, this is plus. So this will become plus. So it will become 0.5I in x direction. Similarly, for this acceleration, it will be, if you look into it, I have to do AA minus AB. Because both of them have the same values, it will come out to be 0I. That means there is no relative acceleration between the bodies. So now the problem is very simple, that I have a displacement, I have a velocity, I do not have an acceleration. So let's simply calculate what will be the time. Time will be S of AB by V of relative, which is equal to 4 divided by 0.5 equal to 8 seconds. Okay, so seems to be relatively very straightforward. No, the problem is we did a big mistake here. Okay, and answer is not 8 seconds with the constraints of the problem. What is the constraint? If you look into this particle A, it has a velocity of 0.3 meter per second and a negative acceleration towards minus x-axis of 2 meter per second. So this particle will actually go like this and come back again and hit this wall of the chamber. Because it hits the wall of the chamber, in what time does it hit it? To calculate that time, you can simply say t is equal to, because my displacement will be 0, so I can simply use the displacement equal to 0, velocity is in this positive x direction, and acceleration in negative direction, so it is minus into 2 t square. So it will come as t square minus point through t equal to 0. So t has two values, 0 and 3, sorry, zero point 0.3 seconds. What is time equal to t equal to 0? That means it's actually just starting, and we know at that point of time it's already on the wall, so displacement at that point of time is already 0. And again the displacement becomes point after zero point 0.3 seconds. That means it's again coming back and hitting the wall at 0.3 seconds, and it might have hardly made any distance. So actually this particle A is not participating in the relative motion, so you can completely ignore it. It's not at all participating. Whatever motion is actually in active form is for particle B, because it has to go and almost hit this wall. So the problem is now confined to that a ball is being launched from B and it has to hit this wall rather than hitting this ball A in midair. So nothing is happening in midair. It's actually whatever is happening, the action is happening on this wall. So now if you come back and solve the problem, that means VB cannot be considered. So VREL is gone. Relative acceleration gone. But SAB still is valid. Okay. Now if you think from this perspective, my VB is equal to minus 0.2 I. What is the acceleration? Is equal to minus of 2I. Now, what will be SAB? Now, it will not be SAB, it will be S of BA, because only B is moving from this point towards it. And because it's moving from this direction towards negative x-axis, now it will be minus 4I. Now, actually, you put all these things in equation of motion. What is the equation? Is equal to, we will use plus half AT square, that formula. And if you put it like this, it will be minus 4I equal to minus 0.2I, sorry, not I, it will be T minus of half into 2 into T square. So this equation, once you actually remove all the negative items and get all the T items on one side, it will be T square plus 0.2T minus 4 equal to 0. So this becomes a quadratic equation, and when you solve this quadratic equation, you will get a negative value and a positive value. Time cannot be negative, time has to be positive, so I'm directly putting that value. So t comes somewhere around 1.9 seconds, okay, which is actually the answer, but you have to give a numerical value in JEE, so it will be 2 seconds. So this is the answer, okay. Now we got the answer, we understood the physics, but let's go back again and see why this 8 answer was coming at all. The 8 answer was coming because I mentioned that there was there is a constraint that it is coming and hitting the wall. Is there a possibility that 8 second is actually the answer? Yes, there is a possibility when we remove that constraint. What constraint? We simply remove this wall. So let's say there is no wall at all. That means this particle A will go like this. Look at my finger. There will go like this and will follow the acceleration. So it will go back, and B particle will continue like this. And at certain point of time, actually they will hit somewhere here. So it has to go like this, and this has also need to go like this. So got it? So actually it can hit at this position and then only we'll get that 8-second answer. So there, this wall needs to go away for this answer to be correct. So always apply physics before applying mathematics while solving a physics problem. It's not mathematics. Yes, you use mathematics to solve a problem, but physics comes first, and you have to visualize the problem. You have to think about it, then only apply the concept. So I have used vectors here. You cannot simply use vectors without understanding the problem. Got it? Thank you.